Have you ever wondered how paleontologists determine the sex of an individual dinosaur? Well, so do paleontologists. See, while there may be morphological differences between certain sexes of certain species, a lot of the time what researchers are left with are just fossilized skeletons of the animal they're trying to study. And even then, it's most likely fragmented. Now, with a large enough data set and through different analytical techniques like microanalysis of bones in certain specimens to scan for specific tissue structures only found within a certain sex, we can, within a reasonable amount of certainty, determine in some species whether the individual was a hen or a rooster, so to speak. Again, though, these methods are super specific and require a lot of data, so any other way to determine the gender of the animal is super helpful. And this most recent study just may have added another tool to the paleontological toolbox. Now, to preface this study only looks at hadrosaur specimens across a few different species. Hadrosaurs being those large herbivorous dinosaurs, otherwise known as duck-billed dinosaurs. But anyways, the study looks at only this group of dinosaurs, so it may not be applicable to other families like ceratopsians or theropods. But what Philip Bertezzo and Denver Fowler observed in multiple hadrosaur specimens were conical damage to the neural spines in the tails of some hadrosaurs. Those are the huge backbones that jut out from the backs and the spinal discs of these animals, and they noticed that these neural spines were broken in seemingly all different sorts of patterns. What the team deduced is that the damage to these spines in these individuals was ruled out to be related to predation and interspecies combat, which left paleontologists to come to one conclusion, that being that when two large animals want to make a smaller one, the likelihood of, say, a multi-ton frisky reptile not being too coordinated and subsequently breaking a few of your tailbones during a certain dance, shall we say, is going to be pretty high. And it looks like the fossils support this hypothesis. Now, is this a definitive way to sex these animals? No, but it is more or less a guiding marker towards it, and it may lead to other discoveries of more definitive ways to determine the sex of these long-gone animals, both inside the family of hadrosaurs and more broadly in dinosaurs as a whole. And while it is rather unfortunate and kind of comical, it's still something that's super interesting to take a look at. By the way, I'm sorry, this video was supposed to come out like a week ago, but stuff got in the way. Anyways, I hope you enjoyed. If you want to learn more about dinosaurs, maybe stick around and subscribe. I'll link the paper in the description down below so you guys can check it out for yourself.